So can anyone tell me what is 3 times 3 times 3 times 3 times 3 times 3 times 3?
Huh?
Let me help you out, Timmy. Over here, we have 1, 2, 3, 4, 5, 6, 7 threes, which we can write as 3 to the power of 7. We call 3 the base and 7 the index, or power. This way of representing the number is called index notation. Now let's look at this set of numbers here. They all have 2 as the power, which means that they can always be split into 2 equal groups. Numbers that can be split into 2 equal groups are called perfect squares. In this next set of numbers, all the powers are 3, which means that these numbers can be split into 3 equal groups. We call them perfect cubes.
Miss Miko, how do we know if a number is a perfect square or perfect cube? Must the powers always only be 2 or 3?
Excellent question, Timmy. Let me explain a little more. Let us look at the number 325. We first have to prime factorize 325 to get the product of its prime factors. Using the factor tree, we find that 325 is equal to 5 times 5 times 13. In order for a number to be a perfect square, we have to be able to split the prime factors into 2 equal groups. In this case, we can split the two 5s into 2 groups, but we only have one of 13, which then cannot be distributed equally into 2 groups. Hence, 325 is not a perfect square. Looking at another example, 216 is equivalent to 2 times 2 times 2 times 3 times 3 times 3. We can also write that as 2 to the power of 3 times 3 to the power of 3. Notice that the powers are 3, which means I can split the prime factors into 3 equal groups. Remember, as long as the powers are multiples of 3, we will be able to split the factors into 3 equal groups, which means that the number will be a perfect cube. Perfect cubes can be cube-rooted to give a whole number. In this case, finding the cube root of 216 is the same as finding the cube root of 3 groups of 2 times 3. When we take cube root, what we are essentially looking for is the value in each group, which is 2 times 3 in this case. So, cube root of 216 is equal to 2 times 3, which gives us 6. Notice that the cube of 6 will always give us the original number of 216 again. In the case of square root, we have to be able to split the prime factors of a number into 2 equal groups. Let us take 225 for an example. By using the factor tree, we find that 225 is the same as 3 to the power of 2 times 5 to the power of 2. Since the powers are even, we know that we can split the factors into 2 equal groups, and so 225 is a perfect square. To square root 225 means to find one group of its factors after they have been split into 2 equal groups, so square root of 225 is equal to 3 times 5, which gives us 15. Checking back, 15 square gives us 225, so we know that our answer is correct. To summarize, we have learnt the index notation where we can express numbers as a base and an index or power. We have also learnt that perfect squares always have even powers in the index notation, and perfect cubes always have powers that are multiples of 3 when written in index notation. To find the square root of a number, we always have to split the number's prime factors into 2 equal groups and take one group as the answer. We do the same for cube root but into 3 equal groups. I hope this summary has helped you, Timmy.
Yes, it has, Miss Miko. Thank you so very much.